Hi friends, welcome to TechieMit. So in continuation of the synchronization related series in the multi-threading series, today I'm going to bring you a new video on the topic of static synchronization. So what is basically a static synchronization? So we'll see with the help of real world example, and we'll approach it by like summing up the logic that will apply for the creating the program. And so let's go for it. So what I'll do, I'll take this designer program. Let's take a program to demonstrate static synchronize. Okay. So yeah. So basically, I've taken a class called the static synchronization. So over here, we'll consider a class such as ATM withdrawal or so, whose purpose is to help the logic to build to withdraw the amount specified, and we'll keep some upper limit for it, upper limit for withdraw purpose. So for our demo purpose, to let's say there must be 10,000, 15,000, 20,000. So there is upper limit for the withdrawal. Say we are keeping it as a fixed amount, and then this class will basically contain the logic for withdrawing the this thing amount from the ATM, and how much amount can be withdrawn, or what is the valid amount, and means it will also contains the user specific messages for it, user specific input and messages. Now also the static synchronization is the main class to demo the threads created, and will invoke the thing, that is the ATM withdrawal class. So that's the basic idea for it. So now let's go for it as some the brief summary that we have discussed. Uh, Consider class as ATM withdrawal. Okay. This basically contains the logic. Basic first important thing is it should contain this public static synchronize withdrawCash method. That is the main method that contains the logic for withdrawing the cash. Specify the return type as void. Okay, and as I told that in the ATM they will take some user input. So the help of scanner class, new scanner, system.in, control shift O. It's imported. So code along with me. We'll take the user input. So mainly the user input in the ATM class we take as the pin. So our assumption would be the ATM, in the ATM the ATM card would be inserted, and we'll be like just taking the ATM pin input. So int ATM pin input scan dot next int. Now this is important that the length of the pin should be valid. and it should contain only 4 characters. So any character is less than 4, and it should be invalid. It should throw message. So we'll handle it. So string ATM pin length integer dot to string ATM pin input. We'll check the length of the input. If ATM pin input pin length not equal to 4, so not equal to 4, it should sorry, dot length, because the string length function will use, and we'll check the length of the string input. It should be 4, otherwise through validation message, as simple as that. This is out invalid pin, please enter valid pin. Total balance, this is the max amount that let's say it's 15,000. Remaining amount, this is one variable that we will consider. So where the remaining amount would be like from the total balance, whatever the specific user might withdraw, and that amount will be withdrawn from the total balance. So simple logic. Check the F. Yeah. One more thing is that we need to take the amount from the user. So yeah, again for that we'll use the sysout basically. Enter amount to be withdrawn. Okay. So let's say if amount is less than or equal to total balance, then it's the valid amount. It can be withdrawn. This out. The remaining amount total balance minus the entered amount. Okay. Remaining balance is the remaining amount that should be remaining post withdrawal of that specific amount from by the user. We'll take it into the variable of the remaining amount. Just expand it so to get the clarity over it. Yeah. Yeah. So half of the work is done. So your design as a TechieMit class, it takes the input from the user, and there is an upper limit that you have set for it, that is 15,000. So any amount within 15,000 can be withdrawn by the user, and it will basically subtract the amount from the remaining amount, and we'll get from the total amount. And if you try to withdraw more, then it should throw an error basically. We can do it here. Yeah, we can just handle in the else condition. This cash cannot be dispensed. $15,000. If this will check the condition if user tries to earn more than 60,000, 70,000, 1 lakh, and so on. So this will be handled by the sales condition. This is the main static synchronization method over here. Post that we have this ATM withdrawal. Public class static synchronization demo. This is the main class. Public static void main method. Yeah, as I told you, it will have basically the same thread state will create an ATM withdrawal class. Yeah. So yeah. So what we'll do, we'll create a runnable object. Yeah, this is the runnable instance. It will create a runnable object, and we will have here logic for creating I less than 1, I plus plus. ATM withdrawal lot. Let's say thread 1 Sam. Let's say one more user do we have, thread 3, new thread. Sam, let's say Sundar is his name. Sam Sundar, and thread 3 name as new thread. It will include the runnable instance. We have overloaded the runnable constructor method, and let's say he's Michael. And let's say thread 3, 4, new thread, runnable. Say Jack. His name is Jack. Okay. So 4 threads we are basically, and we are going to start this thread. Yeah. Thread 1 dot start, thread 2 dot start, thread 3 dot start, thread 4 dot start. Okay. So we have started with the program. It's basically how the classes will behave and what logic would be encapsulated in the class for it, and what is the purpose and what are the messages and what are the user input, how would we accept it, and how would it be like. Note here that if here we need to restrict the input to 1 to only allow one synchronized thread to access the so one thread to access the static synchronized context. That's important. So we have restricted this to two, only one, less than one, should be less than one. So yeah, less than or equal to one, can do it. So it will iterate only once, and yeah, otherwise if you include 2, 3, and will not get proper output in it, and the program will behave abruptly. So I think that's pretty much fine now, because we have created the class, we have included the runnable instance, and we will include the thread with overloaded the thread with runnable constructor, and we include the runnable instance and given the name. So we'll just over here we are going to also do one thing. We'll check that which thread currently executing. Yes. Current thread gate name. This is the thread that is currently executing. So we have taken that thread. So now let's try to run the program. So now let's try to run the program. Run as our application. So it's directly taken the input. So we'll just insert one logger message in it. Just out. Enter your amount. Your amount. Withdraw. Okay. No, this was a mistake. Firstly, we are taking this. Yeah. Your pin. Please enter your pin. This will first ask the pin, and it will validate the pin input. Then it will ask for the enter amount to be withdrawn. It will check amount. If it's valid, it will allow to validate. So we'll just rectify the output. Run it once again. Suppose I enter 12. See, it's giving correct output that invalid pin. Please enter valid pin. So if I give only one. Now here it's wrong, because if you enter valid invalid pin, it shouldn't allow to the amount to be withdrawn. So we'll just rectify the logic over here. Just take it else part. In the else part, and we'll save it. I will run it once again. Three, four. Amount to be withdrawn. Suppose I take it's 500. Thread currently executing is Sam. Amount withdrawn is fine. Remaining balance is 14,500. Correct. So the next input is 4567. The amount let's say is 4. Then it's 100. Correct. Suppose I enter 1456. Amount as 18,000 I enter. Sorry, the cash cannot be dispensed. Please enter amount less than 15,000. See, it's giving the correct output. I'm going to enter. Please enter your pen. See, but if you check over here, the program is going in infinite loop. Why is the case? It's because of this equal. So we should restrict it only to less than 1. When it's not equal to the condition, it will again the program causing the loops will just rectify it. We'll stop it and just decompile it and as Java application. So please enter your pen. I enter 1. Please enter your pen. I enter invalid pen. This is the 4th button. Yeah, see, program is terminated after 4 attempts. If you try to enter invalid input, it is automatically terminated. Previously, it was because the condition was that it was less than or equal to 1. So, purposefully, I've done it for that condition. So, you have to specify it should be less than 1 so as to get the program to loop correctly. So, it should be less than 1. And if I enter some valid input, let's enter all the so the enter in the 1333 there is 1400. At currently executing is Michael, number window is 1400, balance is 13,600. Now it's asking for the second user. Let's say 1800. So it's let's say 489. Using my pen. The amount of withdrawal is 1000. Now it's 4 5. Yeah. So if you carefully see the condition, first was the Sundar, Michael, Sam, Jack, Sundar. So all the threads that are executed, all the threads got exactly once to execute the chance, and we are getting the valid input. It's correctly validated against what input we entered. So if we try to give the proper logic and we like justify the condition by checking the loop, how many times it will iterate, we are successfully able to generate the program in which through a static synchronized method. No, this has to be static synchronized method because using static synchronized it uh, obtains a lock to the entire class rather than a specific just a method. So and just by using because it's a static synchronized, just by using the class name, we will directly execute this method. Otherwise, if it was not static synchronized, we won't be able to execute just by using the class name and the method name. So that's the advantage, and the advantage is it's obtain a lock for the entire class over here. So each thread, what it does, it executes and it actually allocates its critical section for the entire class. That is the ATM withdrawal. So it's like one person going into the ATM, withdrawing his amount, then he returning back. The other person goes and then he returns, withdraws his amount, and he returns back. Likewise and so on. So this is the real case scenario and a simple way to demonstrate the usage of static synchronization. So this series was about synchronization, which initially we include instant synchronization, and we concluded with the synchronization method, synchronization block, and this is also a real-world example of static synchronization. Do keep liking, subscribing, #TechieMit, multi-threading related series. Stay tuned and bye for now.